Hello everybody, and welcome back to my channels where I post tips and tricks for CRNA students. If you are an SRNA or somebody looking to get into CRNA school, or just somebody interested with my topics, please subscribe, like, share, and this is gonna be great. So today I'm going to talk about a different topic that we review into the instrumentation course, and it's called audio gases. So I'm going to share a trick and a tip on how to memorize these different gases. So mainly we have 4 types of gases and a combined gas law. So these laws are Boyle, Chow, and Gay-Lussac. And then we have a combined one. So I'm going to share a trick how to memorize them, and we're going to do some applications and see how we can use them into the anesthesia bedside. So let's start with the laws first. So my trick to remember this is going to be paid TV can be good. So paid T, let's write it bigger, TV can be good. So paid TV can be good. So P, T, and V are going to be my variable for my different gases. The gases works according to the pressure, the temperature, and the volume. So I'm going to put here pressure, and this is going to be my temperature, and this is going to be my volume. And down here, I have my different gases, and this is going to be Charles law, and this is going to be Boyle, and this is going to be Gay-Lussac. I'm just going to put Gale. So paid TV can be good. So in the Chow laws, my pressure is going to be constant. In the Boyle laws, my temperature is going to be constant. And in my Gay-Lussac laws, my volume is going to be constant. So how do I actually apply this? So we do have the combined gas law. We haven't forgot about this, who state that P1 V1 over T1 equal to P2 V2 over T2. Now, let's do the application of the Charles law. Knowing that the pressure is constant, it's not going to change, I'm just going to cross my pressure. And if I want to know what V1 is, V1 equal V2 T2 times T1. Now, because V1 is on the same side as T1, I can deduct that as my volume increase, my temperature increase too. And that's what the Charles law says. As the volume increase, the temperature increase. They are directly proportional. Now let's go to the Boyle's law, and we're still going to use the same equation in the combined gas law. It's going to be P1 V1 over T1 equal P2 V2 over T2. Here, what is our constant is the temperature. So I'm going to cross my temperatures. P1 V1 equal P2 V2. And then if I want to get my P1 equal P2 V2 over V1. Now my V1 here is inversely proportional to my pressure. So according to Boyle's law, when the pressure increase, the volume decrease. And that's what Boyle's law says. Now let's move to the last, the Gay-Lussac law, same equation, P1 V1 equal P2 V2 volume is our variable, T1 and T2. So I'm crossing my volume. So P1 T1 equal P2 T2. So P1 equal P2 T1 over T2. So according to the equation, my pressure varies according to my temperature. So as the pressure increases, my temperature increases as well, because P1 is on the same side and T1. And that's what Gauss law says. So to summarize all the laws, we don't have to memorize them. If you know your combined gas law and you know which one is the variable, you can actually deduct it. And that's why paid TV can be good. It's actually an easy way to memorize it. Charles' laws, as volume increases, temperature increases. Boyle's laws, as pressure increases, volume decreases. And Gay-Lussac laws, as pressure increases, temperature increases. Now, let's do some application to this. I'm gonna make some space here. Let's start with Charles' law. So if we have a gas, let's take some example that has a volume 1 liter at a temperature, volume equal 1 liter at the temperature of 150 degree Kelvin, and we want to know what's gonna be the volume of the gas at the temperature of 200 degree Kelvin. Yep. So if we go back here, we know that P1 V1 equal, in Charles, our pressures are constant, so we're just gonna use the V1 T1. V1 over T1 equal V2 over T2. I'm trying to get my V2. So my V2 equal V1 T2 over T1. So if I plug in my variable, my V1 is 1 liter, my T2 is 200, and my T1 is 150. So my V2 is going to be, oops, I gotta get my calculator. It's gonna be 200 over 150, giving us 1 liter, 1.3 liter. So, and actually we can double check ourselves, because we said according to the Charles laws, as the volume increases, the temperature should be increasing. So we have a first volume of 1 liter with a temperature at 150 K. So if our volume increase from 1 to 1.3 liter, we should see an increase in the temperature as well to 200. So I know I did a good math. Now let's do another application on the Boyle's. On the Boyle's law. So here I have a problem. If I have a gas with a volume of 10, V1 is 10 ml, and the pressure is 50, P1 is 50. Now I want to know what's gonna be the volume of a gas operating at the pressure of the gas operating at 22 ml. What is P2 when I have a volume of 22 ml? Same principle. We saw earlier that in Boyle's, the temperatures are constant, so I'm just going to use the top. P1 V1 equal P2 V2. I'm looking for P2. P2 equal P1 V1 over V2. Plugging in my variable, P1 is 50, V1 is 10 over 22. So that's 500 over 22. Giving us P2 equal 22.7. So according to the law, as pressure increases, volume decreases. So we have our first volume that was 10, the pressure was 50. As pressure increase, volume decrease. Now we have a second volume that is 22. Our volume went from 10 to 22. It increases, so the pressure should go down, and it actually went down from 50 to 22.7. So we're on the right path. Now let's do the last application, Gay-Lussac laws. So if we have a gas that has a temp at 250 Kelvin and our pressure at 250 centimeter of pressure, and we want to know what's going to be the temp, what's going to be the pressure at a temperature of 312 K. Same principle, we know our volume is a constant in Gay-Lussac law, so P1 T1 equal P2 T2, and I'm looking for P2 equal P1 T2 over T1, plugging in my variable T1 P1 250 times 312 over 250, cancel, so P2 equal 312. So according to Gay-Lussac laws, as pressure increases, temperature increases. So now here we have a temperature of 250 and a pressure of 250, and now we have a temperature of 250 and a pressure of 212. So this is now they match together, and that's just the trick and the tip I was going to share in my ideal gas. I hope this helped. If you like the content, please subscribe, like, and share. Thank you, and see you on my next video.